Imagine traffic rolling through 12 intersections, hitting every green light regardless of traffic volume or time of day. Rhythm Engineering has created technology that significantly reduces stops and delays on arterial streets. Its unique artificial intelligence technology is proving to be the most effective adaptive system on the market, and traffic engineers from across the country are buzzing about it.
And this is different than any other system that's out there today.
Matt Sellinger is among a group of curious out-of-state traffic engineers who converged on this corridor in Lee Summit, Missouri to learn how InSync works and to observe it in action.
What we're doing right now, driving this corridor, which was before the system was in, was stops. What they had six, 7 stops along the corridor.
Oh, yeah.
Half of all signals.
And the average speed on the corridor was about 23 miles an hour. Well, the difference in this and traditional video is this has a brain. You know, it can measure traffic, it can see what's going to go on, and then these brains, they talk to each other to say, hey, I'm sending traffic down the street. One says, okay, you know, we'll be ready for it, and then it turns the light green downstream, and it'll go ahead and push them through the system.
And the increasing volume makes it difficult for traffic engineers in Missouri to manage, and just as difficult for commuters to tolerate.
I've driven this corridor for probably about 12 years, and it's horrendous. Every single light is a red light, regardless of traffic. There's a stoplight every single block.
Tom Evans with the Missouri Department of Transportation has been studying this particular stretch of roadway since the early 1990s.
It's a corridor with 12 signals on it, odd spacing, which is very difficult to coordinate with odd spacing, and different volumes of traffic per intersection.
And there's the added issue of a high school exit near a highway interchange.
Over here is Lee Summit High School, and it's going to let out here in about 1 minute. And as you can see over on this approach, there's a lot of traffic building. And on a general day, on any given day, it builds up and it causes a lot of problems and a lot of congestion. It frustrates people, a lot of wasted fuel and time.
Before the Missouri Department of Transportation installed the InSync traffic system, it asked for an independent study of traffic flow. And the results confirmed what commuters already knew about this 2.5-mile stretch.
There were times when to get from one end of the corridor to the other could take up to 8 to 10 minutes on a busy evening.
The data concluded that out of the 12 intersections, most cars encountered multiple red lights, regardless of intense efforts to time the signals, and regardless of whether the driver was traveling northbound or south. After the initial study, Rhythm Engineering installed the InSync system.
An example of how the system works is if you put a traffic person at each intersection with a switch, and they could look up and look down and know exactly what was going on in each direction. It's like we're sitting here and we went, okay, we're going to give green to this direction. Okay, now we're done. I mean, and that's exactly what it's doing, but it's a computer doing it.
Since InSync works in real time, it can adapt to sudden traffic changes, like that school exit piling up with cars right next to the highway interchange.
It's working. It's doing a real good job with it, too.
We're seeing as many as 25, 30 cars queuing up, and we're not seeing queues that back up down onto the highway at all, which is good. It's optimizing as it's supposed to.
InSync is compatible with existing signal hardware. It's easy to install, is simple to set up, and is conveniently monitored from an ordinary web browser on a desktop computer.
We're able to look at the intersections from a remote location on the internet, observe the intersections, not have to drive out to the intersection, and as traffic flows through the corridor, it adjusts automatically.
After InSync was installed and running for several weeks, a post-study was conducted to look at its impact.
I know the travel times were up to 8 minutes before, and I think we've got them down to 3 or 4 minutes.
In one time frame, it's dropped almost, it's in the 90%, the amount of stops that have dropped. And that's just phenomenal. Usually you're looking at 15%, 20% is great numbers, but having them up to the 90s, that's just, I'm impressed.
There are fewer stops and fewer cars waiting on the side street when there is no traffic on the main street. InSync saves time, it saves money, it reduces emissions.
Just simply the fact that all these stops have dropped has got to be a big energy savings. The amount of fuel saved on 10, 15, 20% decrease in stops is a huge amount. It is more than you could really imagine.
Based on research, it's estimated that InSync will save at least 135,000 hours of commuter time on this corridor. Stops are likely to drop by 13 million, saving 139,000 gallons of fuel and reducing CO2s by 224,000 pounds a year. The economic benefit adds up to more than $3,700,000 a year. The average citizen does not normally notice when traffic is running smoothly, but sometimes they do.
I just thought I was getting lucky. You know, I just thought when I was driving, I was like, yeah, God's with me today. They're green. So yeah, it's been nice. It's been very nice.
There probably was an underwriting hope for many years that someone would do what's going on out here, and it's really neat to see that people come together and design a system that does what we have the technology to do.